Where are we headed? We're headed to Providence, Utah right now. We're going to be going to check out some of the latest, greatest technology in laser welding. And laser welding is key to, mass production mode, consistent quality weld. And I'm really excited about meeting these guys because, it's a good group of boys, and they believe in their product, they believe in our product, and they believe that their product is right for our product. So we're going to go give them a chance. We're going to go look. We're going to go see what these guys, what these guys are selling, and see if we can introduce it into our structural workflows.
Say your settings, process parameters are going to customize, and I set up this finished welding one. Configure it, so you can rename in there. Yeah, so I like 2.6. I start on 70% power for like 14 gauge, anything like that. I'm gonna do probably 85.
Steve with Snake River Manufacturing here. I'm with Tyson with Fine Iron LLC, looking at some lasers today. So what we're evaluating today is depth of penetration, consistency of weld, and overall use. How quick is it to use this thing? How quick is the learning curve? How easy can we get this laser process implemented into our production flows? That's what we're learning today. If we can get our sub-assemblies welded together the way I think we can, this might be a slam dunk.
My name's Tyson, I'm a Fine Iron. So I brought these Theo lasers up here with us today. We came to northern Utah. We drove about 4.5 hours, and so did Steve as well. Steve wants to see basically what this thing can do on these joints that are butted straight up. There's no bevel or anything like that. The amount of distortion that we're going to get, how we're going to tack it together, and how we're going to apply this. It's a bit of a big or kind of a clunky gun. This is actually the smallest one on the market right now. How this is going to work with his parts and production. You're going to start with your gun up like that,
okay.
Trying to kind of wrap around about 45 of that corner, and then as you get to about right here, you're gonna level out to about where you're at.
Obviously there's a little bit of a learning curve, like with anything, but it's a quick study with a laser welder. We're going to find out how well this thing holds up to the extreme abuse that we're about to put it through with a big old hammer.
Make some noise?
Yeah. We got another super scientific test with the laser weld and our sludge. Let's go test this out. So we took a couple of whacks. These are our first hits right here. Then we moved over to the corners. Worked over the corners. Here's another really good divot. And you can see we just worked this thing over. But these welds, everything's still holding. I think it'll be a good process that we can fine tune and be able to get more of our product out quickly and efficiently.
Leave it the same for here and here, but I would turn it down to fill these in because it's going to be hard to fill on 90%. It's going to try and blow through everything. Your first 3 passes are just going to blow through. Gotcha. So I'd turn it down to 70, make 3 passes, and turn it back up to 90 and run it. Or wear it off.
That looks good. So we're going to do some more destructive testing. We're taking a SkyTrack. We're going to hook it up to this weldman. Specifically going to be looking at that joint down there. Now we already beat the heck out of this U-frame, and it was impressive to see the laser welder close the gaps that it did. Yeah, now we just really want to test it to failure and see, does the weld tear or does the material tear? What fails first with this application? Because how he was able to burn that material in there, I mean, it was incredibly fast. That's the production speed that we need.
Okay, keep going down.
Holy smokes. Pulled all the material around it off, huh?
Feels like that movie The Sandlot when they're looking at that busted ball.
Yeah, that happened, dude.
Yeah.
Really? You batted the guts out of that ball, man.
So the weak link just becomes the base material. That's how it works.
Well, so
That's how
that's
strong laser welding is.
that fillet rod is at 70,000 series, right?
So it should be stronger than mine.
Yeah, what is it?
Gotcha.
36,000 KSI base.
Yep.
Alright, so the weld is going to be twice as strong as the joints.
Wow.
And even the back one. I was worried about that one. But now look, it took the whole corner piece out of it. Chipped it right out.
It just literally ripped the material apart. Just ripped it. So we're looking at sample pieces where we've worked with the settings to dial them in. Now we're looking specifically for burn through, right? Complete joint penetration. If we look at this bottom weld right here that comes across the width of the tube, you can see it's fully fused, and it actually is almost identical to the natural weld seam, which is what comes from the factory on these structural members. Beautiful welds, full penetration, that's what we're looking for. Hey guys, today was a phenomenal day. We learned a ton of things about laser welding, and we learned specifically how the Theo application would work extremely well in our shop. Full penetration, single pass, 1/4 inch, 1/8 inch, all the configurations, up, down, sideways, any position, these machines can do it. Learned a lot. Fantastic machines. We'll be working with one someday soon.
And then how do you get one? So you give us a call at 435-592-4911, or you hit us up on our socials at Fine Iron LLC or FineIronLLC.com. We'll get you, I'm not going to sell you on a machine. I'm going to tell you whether it's going to work or whether it's not in your shop and how you're going to apply it. And then you're going to come either demo one with us, or we'll get you online to mock up some parts and things like that you want to see in your shop. And it's going to sell itself for you, or it's not going to sell itself for you. Bring a checkbook, because they're nice.